Hi guys, I guess it's really low number of people attending this particular presentation. I hope it's useful for you. This is the complete odd man out of this entire conference. It has nothing to do with gamification and games in general. But then I will bring some interesting things that you need to know when it comes to malware analytics in social networking. Let me just introduce what I'm going to do. This is what I'll be presenting today about malware a little and about malware analytics and techniques that are generally there, what we do in our laboratory, why we do what we do, and then how we do what we do, and finally what makes our model so special that I've come here to present it to you. So what is malware analysis? For any malware, you have your antivirus running on your system. What are you trying to accomplish? You want to finally get a software and then figure out whether the software is a benign software or a malware. Malware just means a malicious software. Don't get this one over it. It's just everything is normal means it's benign software. Like your Adobe Acrobat runs, it's not supposed to be classified as malware. And say a PDF file that contains some exploit runs, it's supposed to be classified as malware. And once we are done with that, I'll go through the three major methodologies that people generally use to classify malware. The first is static analysis. This is the really boring geek stuff. Going through the assembly code. I do that. I don't expect you guys to do that. But you have the executable, you have the compiled one, then you go through the assembly code, try to figure out why it is doing that. And this is kind of really time consuming, and then you have all the problem with obfuscation. You go through Adobe CS, you will find that you'll have to run through 1 gigabyte of obfuscation before you reach the code. And if you actually doing that, it's just time consuming and you don't accomplish anything. And then we have the dynamic analysis. So when you take what is dynamic analysis, imagine this. You have a system, you tell the malware, okay, get it infected, then you see all the events that happen when the system is getting infected, and you learn from it, and that's what actually is kind of popular now. Finally, there is a new technique that's coming up called as the pseudo-dynamic analysis, where you have a set of instructions that are extracted when the software actually runs. So then you can do your assembly level stuff and your obfuscation levels are reduced. These are generally the possible techniques that are there. I wouldn't want to bore you with this, but what we are focused on is called the behavioral based analysis, where we find the behavior of the executable and do something with it. I think after this, it'll be more interesting to people who are familiar with game programming, because it has a lot to do with how games work. What we do is, as I said, we are involved with dynamic analysis. We run the software on a system and see what is the damage. And then, it does look crazy, doesn't it? You allow your system to be damaged deliberately, and then you want to figure out why it's doing that. But then it's not really like that. It's inspired by gaming. Imagine that you have somebody, you play your typical game. You have your Contra guy fighting some monsters or something. You save your game at various intervals, and then you allow the guy to go and fight all these weird monsters. And then when the guy actually dies, you can go back to your saved game, but then now you have intel on how actually he died. You know what the monster that killed him is capable of doing. You know what is there on the route, how the route looks, and you know a lot of information, but then you've not actually lost anything. So that's the kind of thing that we're trying to do. So how do you save the whole system? That's the whole question. And why we are doing what we are doing? Well, it's simple. You see, being social is a catchphrase now. Everyone wants to be social. And when that's being done, you store data like anything. You store files like pictures, JPEGs, PDF files, EXE files. Everything is just stored online. There used to be a time, if you remember, with your email systems, when we used to get flooded with a lot of viruses. Then every one of the email clients started incorporating, we have this antivirus with Norton, and we have Trust Protected with Norton. And even then, today I'm still not sure if all my IMAP syncing is protected by Norton, but in general, at one point of time, we had so much of viruses and so much of malware being flooded through our email gateways that they finally put in an antivirus system in place. But it's happening now in social networks. I do not see a Dropbox that says protected with Norton. Say you are sharing your Dropbox with your friend, and his system gets infected with a virus. You're syncing your system with his system. Isn't it potentially dangerous? It could be even more dangerous if you're in a company. My previous company used to have a Dropbox sync of many files. It was a private Dropbox folder. And imagine one guy's system gets infected. Isn't it potentially dangerous that we are syncing the particular virus all over the network? All these are not really being addressed currently. I mean, I don't deny that it's a major problem, but then over a period of time, I think it's going to blast on our faces when it's finally too late to address it. And while these measures are in place for most of these, and there are still a lot more things to be done. Let's take some examples. These are two papers that were presented recently. The first one shows how a chain exploit of a social network can be done. So basically, imagine there are a lot of people in a social network. One person getting infected immediately brings everyone else into that particular infection. The second one is how to build an anti-social network, rather turning a social network into a botnet. You're all familiar with IRC servers. They used to be the big thing long time back. When IRC servers became the big thing, viruses started to use IRC signals to talk to each other. There used to be a master which used the IRC gateway. There used to be a slave which used to listen to the IRC gateway. And the whole thing propagated. It's not so hard to do the same thing with a Facebook chat. And it's not at all hard to do that with your Google chat. I have done that myself. I've created a botnet with the Google chat. Of course, I don't spread it around, but it's not so hard to think as you. And what are you going to do if there is going to be a botnet with Google chat? Are you going to block Google on your servers? Are you going to block Google IP addresses? There's no way that you can do that. These are highly potential problems that are coming up. So yes, the next thing that worries me the most is, I don't know how many of you know this, but a malware can be embedded inside a JPEG image. It is highly possible. For example, let's take a high resolution picture. It has several megabytes of space. If you change a few megabytes of space into shellcode, exploitable shellcode, it will show up. But then exploitable shellcode needs hardly 10 to 20 kilobytes of data. Imagine 10 to 20 kilobytes of data on a high resolution picture is deleted. It will be maximum one black dot in that whole big picture, and I don't think anybody would even realize that. Just opening the particular picture would make your system susceptible to the malware. These are already out. These malware are existing in the current scenario, but most people do not know this, and we are kind of trying to bypass the situation by ignorance. Okay, so how many of you have used OAuth? I mean, if you're using Facebook and you're developing an app for Facebook, you would be using OAuth and OAuth tokens. But then the main reason why OAuth is popular and is effective is because you're not sharing the username and password, but only tokens. So if a particular app becomes a spammer, the app can be taken out of the system by deleting its tokens. But still, even though the system is good, we see spams every day on Facebook. I mean, I myself see spammers posting on walls like anything on Facebook. You must have seen it too if you use Facebook regularly. There are a lot of pages where you will see spams coming in. These are abuse of the OAuth token, and even a big network like Facebook is not able to avoid that. Even this kind of spamming itself is classified as malware, and we see that every day and we ignore it. But since most of us are power users sitting here, we know what is a spam and what is a real mail, and what is a real wall post, and we try to not click on it. But imagine how many users are actually clicking on these things. And how do we do what we do? There are some things called as software sandboxes. You must have heard of them. The most popular sandboxes that are known are the GFI sandbox, the Norman sandbox, and the Cocoa box. These allow you to run your software in a system and see what the software does and things like that. In our project, we do not use these 3 sandboxes, and then we just take the GFI sandbox for comparison reasons. The next is the power of the social network. Okay, till now I was telling you what's bad about the social network. So there are some good things in the social network that can be used to curtail malware. The first of them being the power of the cloud. So as you know, cloud platform is what, a cloud computing environment is where a social network usually runs because it needs a huge amount of scalability. When a lot of people are uploading a lot of files at the same time, you need scalability. And when there are there's no one accessing it, you need to reduce your scalability. And the cloud has the ability to live and die again, just like a game. So imagine you have Amazon Web Services, or you've ever used Amazon Web Services. You can create an instance on the fly. You can create a micro instance, a macro instance. There are so many instances that you can create. Imagine you create an instance of Windows, try to run on it, and even if the instance gets infected, you're protected because of the virtualized environment of Amazon. And in the meantime, you can analyze all the events that have happened. And what do you do with all these analyzed events? You actually build something called as a behavioral profile, but I'll come to that later. First, let me go to what is a honeypot. A honeypot is something that is exactly what it says. I mean, you have a pot of honey, you see somebody keeping a pot of honey on the road, and it's really good one, then you expect the particular person to go and have it and see how the particular person has it. So in a similar way, we just run a system with absolutely the best environment for a malware to run, and then we see how the particular thing malware executes. In the meantime, we don't care about what happens to the system. It's okay. Let it ruin it. Let it eat the honey however it wants, and that is fine. That's what a honeypot is. And it is just a system where you give the honey to the user, to the malware, and in return you observe events. Earlier, this is actually a very old concept. This is not a new concept. It's a really, really old concept. But it was really expensive to do earlier. But now, thanks to the cloud, it's not really expensive. You can set up multiple instances, you can parallelize stuff, and all this are pretty easy, and the APIs to do that are also pretty simple with services like Amazon, Heroku, and Microsoft Azure and other things. Okay, so I've been talking a lot about these things, and let me talk about my concept. We use dynamic analysis just like the other 3 sandbox and follow the program. Usually, the normal sandboxes like the GFI sandbox and the Norman sandbox, they follow the program. And what we did instead was we followed the system. Following a system is more tedious, but then we did that, and that made the first difference. What that caused is, it did cause us to have some of the worst performances in the industry, and we performed really, really badly compared to any of the other ideas that were ever there. And we in fact had to reevaluate our whole idea because following the system is a really tedious process. And what we did initially was we got output of all these events, and we created a behavioral profile. Actually, here is where I'm telling the game theory comes a lot, because for every user, right, even in a game, you tend to create a behavioral profile of the user on what he's doing based on the events the user does. And based on that, you change the game. I do not know if you have played this amazing game called Dragon Age. It's kind of a famous game. It's in the particular game, you tend to do a lot of actions, and the game and how the game flows after that changes for every user based on the actions that he does. It is not the same game for everyone. Your decisions will change your action completely. And that's something that is achieved over here. So all the actions that each of the malware does will have a different pattern in the behavioral profile, and that's what we're trying to achieve. These behavioral profiles are the cornerstone of every single malware research, because when you have a behavioral profile, that's when you know what the malware is doing. And we observe the system, tries to do what it does and log all the activities, and these profiles can be used to find difference between any malware, the various similarities between malware, and because there are so many possibilities of malware, it is not just changing one file, that's why it's a malware. And to do that, we need these kind of profiles. But then, yeah, this was not enough. Why? We had too much of noise. I mean, we were observing the system, we were not observing a program. If there were tens of dozens of programs running on the system, we had data on every single one of those programs. And when we were comparing results, we had too much of noise. Our results were not good at all. So what we had is, we had a different collection of information that was, I mean, it had huge amount of depth, and we were even able to monitor some of the events that the other systems could not, because those events were specifically meant to bypass monitoring processes. But then we succeeded because we were monitoring a system. But even with this great set of data, I mean, that we could not understand what's happening. So the second point was to actually reduce the noise, and we did that. We did that to a considerable extent using something called as a timeless XML. I think it's not really clear, but okay. The one on the right is the behavioral profile that was before our modifications, and on the left is actually something called as a.
May I have your attention, please? Can the owner of the vehicle number SQ5081C SQ5081C kindly remove your vehicle immediately? Thank you.
Okay, so the one on the left is the timeless XML behavioral profile that we finally arrived at. And what else? Machine learning. As in any other game engine, machine learning is the most promising feature of our system. As we classify more and more malware, we gain more data on how the classification has happened. We gain data on each of the malware, and our model improves after every single classification. That's how we actually finally bypassed a lot of other things. And okay, so what makes our model special? We have a great performance, and after doing all these changes, we outran the best engine in terms of detection capabilities. We were the worst before we did all those modifications, and after machine learning and all these modifications that we did, we have the best analysis engine that's there. We use this machine learning algorithm that was developed by a PhD student, and that engine is called as the Malware engine. And that engine, we applied the machine learning techniques in that engine, and we also applied the same engine to other sandboxes that were available, because we wanted to know if just machine learning had made the difference. I mean, in that case, what happens if we apply the same machine learning techniques to other engines? We optimize the code for other engines, and still we outperform them. So actually our noise reduction has helped a lot. And this is the graph that we got. The red one was our initial engine, which is kind of really terrible. And the blue one is the one with the most used engine, called as the GFI sandbox. And the third one is our current engine, which actually is very, very good in classifying things. It is kind of erratic still, but it's a machine learning thing. Once you learn, then you improve, but then sometimes you do not have the data, so you do perform badly. But still, it is better than better for most cases. Okay, so what is the point of this presentation? Games and social networks have connected the whole world. Okay. And social gaming allows for widespread use of tools that could be disruptive if it is not checked properly. So first thing I would like to ask for game developers to do is have a development criteria of developing by security by design, because it's very easy to get addicted to the process of games, and people spend a lot of times on games, and they don't really mind spending money or anything for games. It's a really addictive field, and it's one of the biggest industries that's actually driving computer sciences today. But if not for security by design, it would all come down with a blinding flash. You imagine this. A lot of you guys have shared PPT files over internet. A lot of you have, like, using SlideShare or something of the sort. You have shared so many things on the internet. On Facebook, you have your photos shared. Even if you're developing for companies, you will have your profile pics at the very least shared. Any of these could host malware if you do not develop it with a proper security by design. The model I talked about till now is actually a very advanced model, which you might not really require for your initial startups. If you're a big company and you have too much of corporate responsibility, then you would require a model of the amplitude that I was presenting till now. But at the very least, try to use something called as a VirusTotal. VirusTotal is a very big database of files. You are allowed to submit any file sample for free. You don't even need to do the cloud computing part. You don't need to spend for the cloud computing part. VirusTotal does that for you, and finally they give you the results. And do at least that much, because it's free. It helps you reduce threats to a huge extent, and it brings, because gaming is huge and social networks is huge. So the very least you could do is to use VirusTotal APIs. It helps. Please do so. So finally, I would like to see if there are any questions that